When reasoning models think too loud. Large reasoning models think before they answer. And therein lies a problem nobody anticipated. A new paper from TU Darmstadt and Athene, Controllable Reasoning Models Are Private Thinkers, demonstrates that reasoning traces routinely leak private information the model was explicitly told to protect. The researchers frame the issue cleanly. When an LRM-powered AI agent books your hotel or manages your calendar, it has access to names, emails, addresses, and credit card numbers. The chain of thought reasoning that makes these models capable also makes them chatty, and that chattiness can be exploited. A malicious third-party service executing a prompt injection can force the agent to regurgitate private data from the reasoning trace, even when the trace itself is hidden from the end user. The fix they propose is elegant. Train the model to follow instructions not just in the final answer, but in the reasoning trace itself. They introduce Staged Decoding, which uses separate LoRA adapters for the thinking phase and the answering phase. The reasoning adapter is optimized to respect privacy constraints. The answer adapter is optimized for instruction following in the final output. Across 6 models from 1.7b to 14b parameters, this approach improved privacy scores by up to 51.9 percentage points on the password evil benchmark. The catch is a familiar trade-off. Better instruction following in the reasoning trace can degrade task performance. The 14b models narrowed this gap significantly, suggesting that scale helps. But the tension between think deeply and think carefully is real and unsolved. This matters beyond academic benchmarks because the failure mode is already appearing in production. Over on r/local LMA, a post about NVIDIA's Nimitron H alleged the model contains what the poster called a silent opinion engine, a gap between the reasoning module's plan and the generation layer's output, where the model narratively rewrites intent during generation. The community was skeptical of the specific claims. No reproducible examples were provided, but the underlying concern resonated. If the model is reinterpreting your query during its thinking phase, you can't trust its own explanation of what it's about to do. Multiple commenters noted similar reinterpretation behaviors in Qwen 3.5 variants. Meanwhile, a brief but unsettling report from r/Gemini AI described Gemini's thinking traces turning very violent during a routine investment query about LNG markets. A reminder that reasoning traces are uncharted territory for alignment, and visible thinking isn't the same as controlled thinking. Supply chain poisoning goes blockchain. A new supply chain attack campaign dubbed Glassworm is using an obfuscation technique that should make every developer pause before their next NPM install. The attack hides malicious JavaScript inside Unicode variation selectors, characters that don't render in text editors, browsers, or GitHub diffs. A loader extracts the hidden payload by stripping the Unicode high bytes and feeding the result into eval. The code is invisible to human review but executes perfectly at runtime. That alone would be noteworthy, but the command and control infrastructure is where things get genuinely creative. The malware uses Solana blockchain transactions for C2 communication. The attacker wallet sends and receives messages via on-chain transactions, costing fractions of a cent. The data is immutable blockchain by definition. Anonymous, no KYC on wallets, and indistinguishable from legitimate traffic on any network that allows Solana transactions. After exfiltrating data encrypted with AES256, CBC, the payload uses a Google Calendar invite to download a zombie proxy agent, turning the compromised machine into a relay node. The malware then steals GitHub access tokens to push copies of itself into Python repositories, Django apps, ML research code, Streamlit projects, pip packages, targeting setup.py, main.py, and app.py files. 2 specific NPM packages, React Native International Phone Number and React Native Country Select, were found carrying the payload with a pre-install hook that skips Russian victims by checking time zone environment variables. The Glassworm campaign shares DNA with the uncensored AI grift ecosystem, where opacity is the product. A detailed teardown on r/local LMA exposed Kryven AI, marketed as a private, uncensored AI tool with a token-based subscription model. Investigation revealed it's a Gemini front-end deployed on Railway behind Cloudflare, with a domain registered in December 2025. When the backend drops a connection, because the actual Gemini API refuses a request, the Kryven front-end displays a fake thinking animation. Deliberate UX designed to cover a technical lie. The community response was swift. Everything Kryven promises is already free via a Llama LM Studio or llama.c, app running locally. The real tell, as one commenter noted, is always the token/subscription model. If the AI is supposedly running locally, why would you need to pay per query? In the hardware security department, a B-Side Seattle 2026 talk demolished Zero Motorcycles' FAQ claim that their electric motorcycles cannot be hacked. Researchers took absolute control of the bike's firmware through its over-the-air update system, which accepts any code structured like a VIN rather than verifying actual VIN ownership. The attack surface is broad.
The bike has an app that talks to onboard electronics via BLE, which take OTA updates including the battery management system. The researchers demonstrated conceptual exploits ranging from disabling brakes via firmware update to setting the battery on fire, all remotely, all persistent enough to survive factory resets. The fundamental lesson isn't that electric vehicles are inherently insecure. It's that OTA update systems without proper authentication are remote code execution endpoints by design.
The open weight map gets redrawn. A comprehensive survey of the Chinese LLM landscape on r/local LMLMA maps the full competitive field. ByteDance's Dubao leads on proprietary usage. Alibaba dominates open weights, especially small models, and DeepSeek, technically a side project of an algorithmic trading firm, remains the most innovative, having invented MLA, DSA, and GRPO. The real surprise is the 6 small tigers: Zhipu, Minimax, Moonshot, StepFun, Baichuan, and 01 AI. All following nearly identical business models of releasing big open-weight models to gain recognition while providing cheap inference services. OpenRouter token usage data tells the current story. Xiaomi's MiMo V2 Pro leads at 1.77 T tokens over 7 days, followed by StepFun Step 3.5 Flash at 1.61 T, with 4 different small tigers in the top 10. Only 3 Western labs made the cut. The underground market for Claude and ChatGPT access in China, mapped in a 99 reply V2EX thread, reveals that Chinese developers still perceive capability gaps in Western models despite the token volume numbers suggesting otherwise. Alibaba formalized what was already apparent in practice, confirming through model scope that they are committed to continuously open-sourcing new Qwen and Wan models covering all sizes. Community reaction noted the Qwen 3.5 family has been next level. Even the 0.8B model impressed, though some cautioned that the Chinese characters actually say more open-source models coming soon without specifying which series. The practical impact of this open-weight velocity showed up immediately. Cursor's new Composer 2 model turns out to be built on top of Moonshot's Kimi K2.5. Apparently fine-tuned using Cursor's own RL pipeline but without the attribution that Kimi's modified MIT license requires for products exceeding 100 million MAU or $20 million monthly revenue. Community opinion was split between this is how open weights are supposed to be used and frustration at the pattern of wrapper companies building on open models without credit. On the hardware side, NVIDIA's Nematron Cascade 230BA3B brought a different architecture to the small model space. Early testing of the QWEN3.535BA3B at IQ4XS quantization showed roughly 100 tokens/second on a single 3090 with 250K context, fast enough to serve as a practical local coding assistant. One user successfully had it complete a 3D snake game in Three.js that multiple other models had failed, and then autonomously used Klein with Context 7 MCP for a Rust/EG UI implementation, fixing its own bugs along the way. The consensus: for the first time, a truly tiny MOE model might be competent enough for real agentic workflows on consumer hardware. Research frontiers. Teaching models to debug. Meta fares towards a neural debugger for Python, introduces a concept that bridges program analysis and neural networks in a way nothing else has. The idea: train language models not just to predict code outputs, but to emulate a full interactive debugger. Step into, step over, step out, set breakpoints, and even predict program states in reverse. The researchers formalized the debugger as a Markov decision process, where states are program locations plus variable values, and transitions correspond to debugger actions traversing a call stack tree reconstructed from execution traces. A fine-tuned 7B parameter model achieves next state prediction accuracies beyond 90% across key actions, while even a 150M parameter model trained from scratch on 80B tokens reaches competitive Cruxeval scores of 52.3 input and 57.0 output on pass at 1. The most intriguing capability is inverse execution. Given an arbitrary program state, the neural debugger can infer plausible preceding states or inputs without ever running the program forward first. This matters for fuzzing, test generation, and debugging scenarios where the execution environment is unavailable or partially specified. The fundamental limitation is that inverse prediction is inherently ambiguous. Sorting destroys input order. Addition is many to one, but the model handles this by sampling from a conditional distribution over possible predecessors. Accuracy degrades with prediction horizon. The more states the model must skip, the less reliable the prediction. But larger sampling budgets partially compensate, suggesting test time ensembling as a viable path forward. The mathematics of extreme quantization received a detailed community treatment, breaking down Microsoft's BitNet approach where model weights are constrained to just 3 values, -1, 0, and +1. This ternary representation means matrix multiplications become additions and subtractions.
No floating point multiply operations needed. The compression is dramatic 1.58 bits per weight versus 16 or 32 in standard models. But the engineering question is whether the accuracy trade-off is acceptable at scale. The post walks through the quantization-aware training process, the centralization step that shifts activations to zero mean before quantization, and why ternary works better than pure binary -1, +1 by allowing the zero state to effectively turn off weights. A new project called ATLAS Adaptive Test Time Learning and Autonomous Specialization claims to achieve 74.6% live code bench pass at 1 with a frozen 14B model on a single consumer GPU, up from 3.641% in its previous version, through constraint-driven generation and self-verified iterative refinement with no fine-tuning or API calls required. The community flagged that some of its architectural descriptions, like geometric lens CX energy field, appear to be Claude-generated documentation cited as research, so the claims merit independent verification.
Developer tooling, cron jobs beat agents. An essay from Holland Ventures makes a case that should be uncomfortable for the agentic AI hype cycle. For most real automation needs, you don't need autonomy. You need a cron job. The author built a pipeline that pulls from roughly 100 sources every morning, runs everything through Claude Sonnet, and posts a curated intelligence brief to Slack. Total cost, about $1.50 per month. The stack is Trigger.d, EEV code first automation. Zapier but you write TypeScript, Gina Reader for article extraction, Supadata for YouTube transcripts, and Algolia for Hacker News data. The 6 parallel fetchers handle HN, newsletters, company blogs, Reddit, YouTube, and Twitter via RSS. Claude returns structured JSON grouped by theme, formatted as Slack block kit. The pipeline runs in under 2 minutes. And the compound value isn't just the daily digest. It's that every API key added for one automation is already configured for the next. Hugging Face's HF mount addresses a gap in model infrastructure that has been hiding in plain sight. Why download a 20 GB model when your code only touches a fraction of the weights? The tool mounts Hugging Face repos and buckets as local file systems via Fuse or NFS, fetching files lazily on first read. You can from pretrained /tmp/gpos, and only the bytes your code actually touches hit the network. The NFS backend works everywhere without root access, and the Kubernetes CSI driver enables the same mount semantics in production clusters. The agentic storage pitch is telling. Agents don't need complex APIs. They thrive on ELs, cat, find, grep, and composable Unix pipelines. The Y Combinator CEO skills library has become the latest reference architecture for structured AI-assisted development. A walkthrough demonstrates 5 key skills. YC office hours, which pushes back on assumptions, asks for evidence of demand, and identifies the minimum viable wedge. CEO review, which searches for hidden 10-star products within your idea. Design consultation, which pulls competitor screenshots and proposes creative risk-taking. Engineering review, which pressure tests architecture decisions. And document release, which cross-references code, changes against documentation to prevent drift. The underlying philosophy is that vibe coding moves fast but breaks things. These skills impose the discipline that experienced product builders apply intuitively. Similar structured workflow thinking appears in Superpowers UI, a port of Jesse Vincent's Superpowers methodology to OpenWebY that enforces design before code via hard-gated brainstorming, auto-generates specs and plans using isolated subagent contexts, and supports both autonomous cook and human-in-the-loop ask modes. Drivline Research's auto-research Claude Code ports the Carpathy-inspired autonomous experiment loop as a pure Claude Code skill. No MCP server, just instructions the agent follows with built-in tools. The demo is compelling. 22 autonomous experiments took a fastball velocity prediction model from R-squared 0.44 to 0.78, predicting within about 2 miles per hour from biomechanics alone. For those building skills from scratch, a best practices guide from Minjesh codifies the emerging conventions. Skill.md under 500 lines, flat one-level deep subdirectories, just-in-time file loading to keep context windows lean, and trigger-optimized front matter descriptions that function as the skill's discoverability layer. The validation methodology. Discovery testing, logic simulation, edge case attacks, architecture refinement. All done in collaboration with LLMs themselves, reflects how meta the tooling ecosystem has become. Agentic AI gets physical. Claude's new computer use capability got an entertainingly unscripted test. A user had it play old-school RuneScape's Tutorial Island, navigate WhatsApp conversations, and browse the Stocks app. The RuneScape test was revealing. Claude successfully created a character, caught shrimp, chopped trees, and lit fires, understanding the mini-map navigation and UI elements, though it struggled with precise click targeting, repeatedly clicking trees instead of the fire. The WhatsApp test was more impressive. Claude autonomously read a stressed friend's messages, composed empathetic responses, handled an inside joke curveball about flirting with someone's mom, and correctly identified when the conversation had concluded. The interaction speed was notably faster than local open source alternatives, though the thinking latency between actions adds up. As the tester noted, this capability isn't novel. Open source models like Qwen 3235 BVL have done browser navigation, but the polish and speed of the integration are meaningful. On the security evaluation side, Dreadnought is building what amounts to MLOps infrastructure for security agents. Their 2.0 platform includes a hub with 600 plus tasks, mostly Docker-composed environments from CTFs, an algorithmic red teaming module tap, a goat-style search rather than hands-on keyboard, an evaluation framework that ties tasks and capabilities together, training modules backed by Ray for local model inference, and DSSC-style optimization. The pricing thesis is significant. If tokens and micro VMs cost fractions of a cent, then security assessments, traditionally priced by how much have you got, can follow AI native unit economics. Their forthcoming Worlds product synthesizes entire network environments for agent training, eliminating the painful process of standing up enterprise networks and VMs. The core insight: domain expertise is being commoditized by AI, so the value shifts to infrastructure that makes it repeatable, measurable, and deployable. Netrix, an open-source street-level geolocation engine, demonstrates what becomes possible when computer vision pipelines get democratized. The three-stage system uses Cosplace for global visual place recognition, 512-dimensional fingerprints, sub-second index search, ALIKED, /disk plus light glue for geometric verification, and RANSAC for filtering false matches. Upload any street photo, get precise GPS coordinates, sub-50-meter accuracy with no landmarks needed. The tool runs entirely on local hardware and has already been used for missile strike geolocation and conflict monitoring. The legal disclaimer is telling: designed for legitimate OSINT research, investigative journalism, human rights monitoring. But the technology is inherently dual use. Policy moves, Pentagon standoff, and EU privacy win. The Anthropic-Pentagon standoff reached a new phase when a federal judge called the Pentagon's ban of Anthropic troubling. The dispute, which escalated from a contract disagreement over usage terms to Trump calling the company radical left and ordering federal agencies to stop using its products, now sits in federal court. Anthropic's position has been consistent. They want two guarantees: no mass surveillance of American citizens, no autonomous weapons without human oversight. The Pentagon's position has been equally firm: unrestricted access for all lawful purposes. Community reaction was divided between those who see Anthropic's stance as principled and those who argue a software vendor shouldn't have veto power over how the DoD uses a product it purchased, noting the DoD has legal authorization to build autonomous weapons whether you morally agree or not. In a concrete privacy victory, the European Parliament voted to end Chat Control 1.0, meaning that as of April 6, 2026, Gmail, LinkedIn, Microsoft, and other large platforms must stop scanning private messages in the EU. The original legislation had required mandatory client-side scanning of all private digital communications in encrypted apps, what privacy advocates had called the largest blanket surveillance regime ever proposed in the democratic world. The technical reality always undermined the rationale. Offenders could bypass via pre-encryption steganography and jurisdictional evasion, while false positive rates at scale would flag millions of innocents daily. The Parliament's decision doesn't end the broader debate. Chat Control 2.0 proposals are still circulating, but it establishes that universal message scanning is a political loser, at least for now.